Okay, I'm going to look at this area model and see if I can figure out how to write an equation from it. So I have a rectangle here, and we know that if this is the width of the rectangle, then this must also be a width. And if this is the length, then this must also be a length. And we know that if I take the perimeter, I have 2 lengths plus 2 widths, and that gives me the perimeter. I also know that if I want the area, I'm going to take the length times the width, and that's going to give me the area. So I'm going to use those two facts, and I'm going to say that I have a rectangle whose perimeter equals 100. So I'm going to say, all right, 100 must equal 2 lengths plus 2 W's. Well, what if I only want 1 length and 1 W? Then that must be 50, because that's half of 100. And I only need half of the perimeter, so half of 100, or half the perimeter, would be 50. Okay, so now I want to know, how would I figure out the length if I knew the width? Okay, if I knew the width, then I could say 50 minus the width would give me the length. And if I knew the length and wanted the width, I could say 50 minus the length would give me the width. Okay, so there's two different ways of looking at that. Now let's go back up here and use our area equation to figure this out. So I know because of substitution that if I know what W equals, I can substitute it in for any place in an equation where I have a W. So I know that W equals 50 minus L, and I have a W up in the area formula, so I'm going to say area would equal the length times 50 minus the length. And I have an equation for the area of this rectangle in terms of just A for area and L for length.